Okay, hi guys. So in this lecture, we'll be seeing more examples of esterification before going on to comparing the rates of esterification and then we'll see saponification. Okay, so let's get started. So we have first example that OH 18 okay, and we are reacting it in acidic medium, providing some heat. What would be the final product? So obviously this OH would be gone with this H, and this O would be getting attached to this carbon atom, forming a 1 2 3 4 5 member ring. Okay, okay, so 1 2 3 1 2 3 and finally 4. This will be the product form, and this is a cyclic ester which is formed. Okay, and we have then substituted CH2 C double bond OH and O18H. Again, what will happen in acidic medium? Heat it. What will happen is, again, this H and this OH will get released from the reaction, and this O will be forming a bond with this carbon atom. As a result, we'll be getting a 3-membered ring formed. Rather 1 2 3, yeah, sorry, 1 2 3 4 5 member ring. Those two carbon atoms from benzene is also there, right? So we'll be getting something like this will be the product form. Okay, let's look at another example. Here we have something like CHO and CO2H here. Then we are reacting it in presence of NaBH4 to get compound A, which is then reacted in acidic medium and little bit of heat to form compound B. So we have to determine compound A and B. So obviously compound A would be NaBH4 would reduce CHO but not CO2H. So as a result, we'll be getting something like CH2OH. Okay, and here we'll be getting CO2H. Okay, and then acidic medium, and we are heating it, we'll be getting compound which is called a ester, something like this. Okay, let's look at another example. We have this compound on, again, hydrolysis in acidic medium gets to compound A. Again, H plus, in we are providing heat, get to compound B. Okay, what are A and B? That has to be determined. So A would be, obviously we are hydrolyzing a nitrile group, so what will be getting? A carboxylic acid. We have seen it. Okay, then we are providing heat in acidic medium, so what will be getting? Again, a ester or esterification will take place, and we'll get something like 1 2 3 4 5 member ring. Okay, this would be the product. Okay, this would be product A and this would be B. Okay, let's discuss another example. This is CH3 C double bond O, OAT ester, and we are passing basic medium in it in presence of water. So what will happen in this reaction is, obviously OH would be getting attacking to the electrophile which is having delta plus, so we'll be having something like this as the intermediate. Okay, and OAT here. Next, what we will be getting? Again, it will be forming double bond. As a result, OET minus would be leaving, and we'll be getting something like this compound. Okay. Now what we'll be getting is, sorry, OET minus. Now what we'll be getting is, again, this acid base reaction will take place. Okay, in which we'll be getting something like this OAT minus takes away the H plus. We'll be getting this, and ATOH formed. Okay, so why should it go in the forward direction? The equilibrium should shift in the forward direction. So the reason is, obviously, this is a stronger acid and this is a weaker acid. Okay, so hence this it goes in the forward direction. Okay, let's see another example. We have ester plus, please remember this, ester plus in H plus. What will happen? So what will happen is, again, this will actually attack on this electrophile, and as a result, what will we be getting? O negative, OR and OR dash, and then we'll be getting something like, again, double bond restored, and this OR will be leaving. So we'll be getting something like, again, in an acidic medium, so we'll be getting C double bond O, OR dash plus ROH. Okay, so for the reaction to go into forward direction, you have to compare the acidity of these two. Okay, so if it's a stronger acid than this, and a strong nucleophile, you can say. Okay, so this reaction can go into the forward direction. Okay, now let's actually compare the rates of esterification. Okay, so if you compare the rate of esterification for the following alcohols, what will you get is that as the number of carbon atoms or the number of substituents attached to this carbon atom increases, the nucleophility decreases. Why? Because of obvious steric hindrance reasons. Okay, because in the complex you or in the tetrahedral complex, you would have seen that this compound actually attacks the acidic the carboxylic acid, hence nucleophility matters. Okay, so nucleophility decreases, okay, due to steric hindrance. So in the as the tetrahedral complex is the RDS for this reaction. Okay, so in that complex, steric hindrance of this group would be highest. Okay, next let's see another topic, which is called as saponification. We have actually already seen the example of saponification, which is nothing but the hydrolysis of ester in basic medium, but again we'll formalize it and make it another concept, and we'll again revisit it. So we have already seen what actually happens in OH minus or basic medium. So obviously this OH minus would be will be attacking to this carbon atom, and will be getting something like OET minus, and then again what will happen is this OET minus will take place, this H plus and acid base reaction will take place. As a result, we'll be getting something like this and ETOH. Obviously this is a stronger acid than this, hence the reaction will go favor the forward direction. Okay, so hydrolysis of ester in basic medium is known as saponification. Okay, so with this we come to an end of this lecture. In the next lecture we'll be seeing some notes on saponification, and then we'll be seeing Baeyer-Wilker oxidation. Okay, so till then, good luck and goodbye.